very good afternoon to all of you and a warm welcome once again on the YouTube channel of BYJU'S Exam Prep. I'm Gaurav Gupta and today I welcome all of you to our fourth session in which we'll be learning some of the calculation techniques which will definitely help you in any aptitude based examination be it MBA entrance examinations or be it SSC, Bank, PO, UPSC, whatever kind of examinations you are taking on, the examinations in which you will require to basically speed up your calculations. These particular sessions will help you in all those examinations. So, calculation technique session number 4, and today we'll be talking about the digital sum, the uses of digital sums, the applications of digital sum in two different areas. So, friends, welcome back once again on the YouTube channel of BYJU'S Exam Prep. I believe I am clearly audible and visible to all of you. So we are good to begin this session. So calculation techniques, session number 4. Previously, I have taught you how to speeden up, how to fasten up your calculations when it comes to percentages, when it comes to finding squares and square roots. And in my last session, we had a discussion about cubes and cube roots. So in case anyone has missed any of these sessions, please look at the recordings. All the recordings are available on YouTube. So yes, you can go back and have a look at these sessions as well. But today we'll be talking about the applications of digital sum in improving your calculations. And there will be one more area where the application of digital sum will be used. So let's first of all quickly define the agenda of this session. So at the beginning of the session, I'll be telling you what the digital sum is. So an introduction for the digital sum. Then after that, we'll be talking about the application of digital sum in improving or in increasing the speed of our calculations. So you don't have to actually do the multiplications or divisions. Digital sum is a method using which you can basically reduce the amount of calculations that you are doing. All right. So first application, first usage will be in speeding up your calculation, and the second is the divisibility rule. So there are a few divisibility rules in which this digital sum will be applicable. All right, so this is the entire agenda for today's session, and now let us have a look at what is a digital sum. So let's begin this session. Now, digital sum is basically the sum of the digits of any given number up till a single digit. So we keep on adding the sum of the digits. We keep on adding the digits till the time we'll obtain a single digit number. I'll take an example for that. Okay, so this is the basic way how to calculate the digital sum. So let's say the number is 4763948, a very big number. Now what I'll do is I'll calculate the sum of the digits of this number. All right. So 4 plus 7 is 11. I'll go very slow at the beginning. So 4 plus 7 is 11. 11 plus 6 is 17. Plus 3 is 20. Then 29, 33, and then 41. So 41 is the sum of the digits. Now you can observe that once I've calculated the sum of the digits, I have obtained a 2-digit number. Now to further calculate the digital sum, just add these 2 digits as well. Okay, so 4 plus 1 is 5. So once you have obtained a single digit number, that is the digital sum of this number. All right, so 5 is the digital sum of this number. Am I clear? I'll take one more example to clarify this thing. So 392857. Let's say this is the number. So let's add all these numbers. So 3 plus 9 is 12. 12 plus 2 is 14. 14 plus 8 is 22. 22 and 5 is 27. And 7 it is 34. Now 34. Now add these two numbers 3 and 4. So 3 plus 4 is 7. Now I have obtained a single digit number, and that is the digital sum for the given number. All right. Okay. Now there is one more way you can calculate digital sum. There is one more usage of digital sum. Now digital sum is basically the remainder obtained when the number is divided by 9. So number को 9 से divide करो and obtain the remainder, and that is the digital sum as well. Now, you will think that whenever I'll divide any number by 9 and obtain the remainder, then the values of the remainder will range from 0, 1, 2, and so on up till 8. 8 is the maximum value of the remainder that is obtained. Alright, I'll repeat. Any number when divided by 9, the remainder obtained is also treated as the digital sum. Alright, now once any number is divided by 9, the range of remainders, the different values that the remainder may have will be starting from 0, 1, 2, 3, 4, 5, 6, 7, and 8 will be the maximum value. All right. So while calculating the digital sum of any number, what we'll do is we'll treat the digital sum of 9 equivalent to a digital sum of 0. So 9 will be treated as 0 while calculating the digital sum. All right, fine. So let's say any number is there whose digital sum comes out to be 9. It will be treated as 0. Every time it will be treated as 0, and that's it. So 0 will be treated as 0, 1 will be treated as 1, 2 is 2, 3 is 3, but 9 will be treated as 0 while calculating the digital sum. Now, this particular thing will also help you in calculating the digital sum of any number in a faster way. I'll take an example. So let's take this example that I have taken up there. So 392,857. All right. Now, since every value of 9, every digital sum of 9 can be treated as 0. So in this number, you can see a 9. You can completely ignore this. All right. So wherever you see a 9 or a sum of 9, you can completely ignore that to calculate the digital sum. Okay. So I have a 9. I can ignore this. Then you can see that 2 plus 7 will also be equal to 9. You can ignore this as well. All right, then calculate the digital sum of the remaining digits. So 3 plus 8 is 11. 11 plus 5 is 16. So the digital sum here is 16. Further, I'll add 1 and 6, and it will give me a digital sum of 7, which is absolutely the same. Which is absolutely the same in the example that we have calculated earlier. All right, since the number is same, the digital sum will be same, but this is a faster way of calculating digital sum. All right. So I'll quickly rephrase whatever we have done. So digital sum of any number is basically the sum of the digits up till a single digit number. So we'll add all the digits. Whatever number is obtained, if it is a single digit number, then that will be the digital sum. But if it is not a single digit number, then add the sum of the digits of the sum that is obtained. Okay, so keep adding these digits until you will get a single digit number as the result. Also, digital sum can be treated as the remainder obtained when the entire number is divided by 9. Now, since the range of remainders is from 0 to 8, so I can say that we can treat the digital sum of 9 equivalent to 0. So, जब भी digital sum 9 आ जाएगा, उसको आप 0 भी assume कर सकते हो. Alright, and you can use it to quickly calculate the digital sum of any set of numbers. All right, so this is the introduction about digital sum. Now let us have a look at the application of digital sum in calculations. So calculations, let's speeden up the calculations using the concept of digital sum. So I've taken some examples including multiplications, additions, divisions, subtractions. So different arithmetic operators I have taken to explain how we can fasten up our calculations using digital sum. So this is one such example. Now you are given an expression and you'll have to calculate the value. All right. Now you will encounter these type of things in different questions. Okay. So at the end of the question, you may get a particular expression after solving which you will have to mark your answer and you are given the options. Now, obviously, a very famous technique of matching the unit digit can be used. Okay, so if I'll calculate the unit digit of this entire result, 8 multiplied by 2, 8 multiplied by 2 is 16. So 6 will be the unit digit of the first calculation. Then plus sign. And then unit digit of the second part will be 3 multiplied by 3, that is 9. Now 6 plus 9 is 15. So 5 will be the unit digit of the result. So if among the options, you have options which have different unit digits, or if you have only one option which has a unit digit of 5, you can straight away mark that option as the answer. But in our case, I have taken all the 4 options which have the same unit digit. Good afternoon, Pratyush. Good afternoon. So in this example, I have taken all the options which have the same unit digit. All right. So let's see how we can treat this question to find a correct answer using the concept of digital sum. Okay. Now I'll be calculating digital sum of these numbers separately. So digital sum of this number, 2 plus 3 is 5. 5 plus 8 is 13. Now 13 is the digital sum. Now further I'll add 1 and 3 and I'll obtain 4. Alright, 4 is the digital sum here. Multiplied by, then the digital sum of this next number. I can ignore 9 as I have told you earlier. Right? So every value of 9 can be ignored and it can be treated as 0. Okay, so 9 को ignore कर दिया, remaining is 4 plus 2 is 6. So 6 is the digital sum here, plus 9 ignore कर दिया, 6 and 3 ignore कर दिया, so the digital sum will come out to be 0, multiplied by, now understand that whenever you will obtain 0, 0 multiplied by any number will be 0. Okay, so there is no need to calculate the digital sum of the last number. Still, if I'll calculate it, 8 plus 4 is 12, 12 plus 3 is 15, so 15, and then 1 plus 5 is 6. Okay, so the expression here is 4 multiplied by 6 plus 0 multiplied by 6. Now 6 into 4, the first part is 24 plus 0, and that is 24. And further you can calculate the digital sum. So 2 and 4 add करके कितना आ जाएगा? It will be 6. So I can see that 6 is the digital sum that is obtained for this expression. Okay, 6 is the digital sum that is obtained for this expression. All right, fine. So let's see what will be the answer among these 3 options. Okay, now music core says multiple of 15 can be used here. Yes, so music core, this is a specific case, like you have obtained, you have determined that multiple of 15 should be the answer probably, but I'm just explaining you the application of digital sum. Okay, so there may be plenty of questions in which you can speeden up your calculations using this method. So expression का digital sum कितना आ गया? 6 आ गया. Now let's check the digital sum of these options one by one. Okay. Now for the first option, remember that I can eliminate 9. So 4 and 5 will become a 9, 8 and 1 will become a 9. So remaining digits are 2 plus 5, that is 7 is the digital sum of the first option. So I need a digital sum of 6. I'm getting a digital sum of 7. So option A will not be the answer. Let's move to the second option. 4 and 5, 9. I'll remove this. एक और 9 आ गया, remove कर देते हैं. And then 2 plus 5 is also 9. So the digital sum of the second option is 0, which is not matching with the value of 6. So second option is also eliminated. Let's check the third option. So 4 and 5 removed, 1 and 8 removed, 1 and 5. 1 plus 5 is 6. This is matching with the digital sum that we have obtained. So option C can be the answer. Let's finally check option D. So 4 and 5, 9, 1 and 8, 9, and 3 plus 5 is 8. All right. So among the options, there is only one option, that is option C, which is matching with the digital sum of our expression. So the correct answer will be option C. All right. So this is how you can use the method of digital sum to calculate the answer or to match the answer among the options for the expressions like this. Okay. Let's check one more question. Let's take one more example. So this is the multiplication that we'll have to do. 73 multiplied by 718 plus 392 multiplied by 644. Now let's check what will be the digital sum. So 7 plus 3 is 10. Then further add 1 and 0 and you will obtain a digital sum of 1. Then multiplied by 1 and 8, 9. I will ignore this and I'll be left with 7. So 7 in this case, plus sign, 9 is removed, 3 plus 2 is 5, so a digital sum of 5, multiplied by 6 plus 4 plus 4. 6 plus 4 is 10 plus 4 is 14. Now 14 में add कर दिया 1 and 4, I'll get a 5. Alright. Now let's simplify this. So this expression will become 1 into 7 is 7 plus 5 into 5 is 25. Now 25, add 2 and 5 and it will become a 7. So I'll get a 7. So 7 plus 7 is equal to 14 and digital sum here will be 1 plus 4, that is 5. So the digital sum of my result should be equal to 5. All right. Digital sum of the answer should be equal to 5. Now let's check these options one by one. So first option, am I able to make a 9? So 3 plus 4 plus 2 is 9. So remaining digits are 8 and 8, that is 16. And 1 plus 6 will become a 7. I need a digital sum of 5. So option A cannot be the answer. Okay. Now option B, 3 plus 4 plus 2 is a 7. Also 1 plus 8, sorry, 3 plus 4 plus 2 is 9. I'll remove this. 1 plus 8 is equal to 9. So I'm left with only 8, which is not matching with the digital sum that I require. So option B is also not the answer. Third option, 3 plus 4 plus 2 will be a 9. So remaining digits are 5 and 6, that is 11. So 6 plus 5 is 11. Then in 11, 1 plus 1 will become 2. So I have got a digital sum of 2. So option C cannot be the answer. Now since I'm left with only one option, you can straight away mark that one. But let's check this if I'm getting a digital sum of 5 or not. So 3 plus 4 plus 2 is 9. I'll remove this. In दोनों को add किया. 8 and 6 is 14. Further in 14, 1 plus 4 is 5. So finally a digital sum of 5 is obtained and that should be the answer. So option D will be the correct answer for this one. All right. Okay. Now let's take one more example. Again, multiplications, but in this case, there are some subtractions as well. Instead of additions, there are some subtractions as well. Okay. So first case, 9 is removed. The digital sum is 3. All right. Multiplied by 4 plus 3 is 7. Now 3 into 7 is 21 and then 21 may 2 plus 1 will be 3. So 3 will be the digital sum of the first part. Separated by minus sign, then 4 plus 8 is 12. Okay, 4 plus 8 is 12. 12 में 1 plus 2 ऐड कर दिया तो 3 आ गया. 3 multiplied by 1 plus 3 is 4 and that will give you 3 into 4, that is 12, a digital sum of 12. 12 का digital sum कितना हो जाएगा? It will be 3. Okay, so 3 minus 3, then separated by plus sign. Now in this case 2 plus 7, 2 plus 7 will be 9. 9 will be treated as 0. 0 multiplied by anything will be equal to 0. Okay, so 3 minus 3 plus 0. Ultimately, the digital sum should come out to be 0 for our answer. Okay, options check करते हैं. Options में कहाँ पे digital sum 0 आ रहा है? So 6 and 3, option A, 6 and 3 will give you 9. I'll remove that. So remaining digits 1 plus 4 will give you a 5, which is not equal to 0. I need a digital sum of 0. Okay. Second option, add करते हैं. 1 plus 6 is 7. 7 plus 7 is 14. 14 and 4 is 18. 18 will become a 9. 9 can be treated as 0. So this is matching. So option B can be our answer. Option C check करते हैं. 6 and 7 13 and 4 17. 17 में 1 plus 7 is equal to 8. So digital sum of 8. Option D, 1 plus 6 is 7. 7 and 8 is 15 and 4, 19. 19, 1 plus 9 is 10. And then in 10, 1 plus 0 is equal to 1. So a digital sum of 1. So only option B is matching with our required digital sum, and that will become the answer for this question. All right. I hope I am very much clear with these techniques that I'm using. Okay. Now let's take one final example to understand the digital sum. Let's take one final example. All right. Okay. And then we'll move on to the second application of digital sum. Okay. Now, in this case, division is involved. So let's see how to handle divisions. 949. Now, 949, in this case, I can ignore 9 and 9. So I'll obtain a digital sum of 4. Divided by, next is 13. 1 plus 3 is 4. Plus 4 plus 3 is 7. Multiplied by 1 plus 2 is 3. Okay. Now 4 divided by 4. 4 divided by 4 is 1, plus 7 into 3 is 21. Now 21 may, this will become 3. So 1 plus 3 will be equal to 4. So a net digital sum of 4 should be obtained. Let's check. Now I need 4. So 5 and 8. 9 ignore ho jayega. 5 and 8. 8 and 5 is 13. And this will be equal to 4. Matching with the digital sum. Option A can be the answer. 9 and 9 ignore kar diya. In the second option, digital sum is 5. In the third option, 9 remove kar diya. 5 and 6 is 11, which will give me a digital sum of 2. Last option, 9 remove ho gaya. 5 and 7 will give me a 12, a digital sum of 3. So only option A, which has a digital sum of 4, is matching with the correct answer. Absolutely, Pratyush. So your answer was absolutely correct. Okay. So these are very basic examples that I've taken, but you can extend this technique to any random calculation expression to get the final answer using digital sum. All right, fine. Now let's move on towards the second application of digital sum. So divisibility rules using digital sum. Now at the beginning of this session, I've already told you that digital sum is basically the remainder obtained when the number is divided by 9. So digital sum technique can be used to calculate the divisibility rule of 9 as well as 3. So yes, there are two numbers in which this particular divisibility rule can be used. All right. So first of all, let's have a look at the divisibility rule of 9. So let's say you are given a very big number, 3, 4, 3, 6, 9, 2, 8, 7, 5, 3. Let's say this is a number that is given to us and we want to check whether this number is divisible by 9 or not. All right. So this is the first thing. I'll check whether this number is divisible by 9 or not. Now, if this number is divisible by 9, the remainder will be 0. If this number is not divisible by 9, then the remainder should also be calculated. And we can calculate this remainder using digital sum method. All right. So let's first of all calculate the digital sum of this entire number. So digital sum calculate करने के लिए again I can remove 9. So 9 को remove कर सकते हैं तो एक 9 remove हो गया. Then 2 plus 7 is also 9. I can remove that. 6 plus 3 is 9. I can remove that. Then 4 and 5 is equal to 9. I can remove that. I can ignore them. Okay. Now let's check the remaining digits. So 3 plus 8 is 11. 11 plus 3 is 14. Now 14. Now add these two and you will get a 5. Now for any number, if the digital sum is equal to 9 or 0, if the digital sum is equal to 9 or 0, then the number will be divisible by 9. Otherwise, it will not be divisible. All right. I'll repeat. If the digital sum is either 0 or 9, then the number will be completely divisible by 9. If the digital sum is not equal to 0 or 9, then the number is not divisible by 9. All right. So in our case, we have obtained a digital sum of 5. So I can say that since 5, this is the digital sum and this is not equal to either 0 or 9. So this number is not divisible by 9. So let's say this is the number n. So n is not divisible by 9. Now, if n is not divisible by 9, then we should obtain certain remainder when n is divisible by 9. And this remainder is equal to the digital sum that is obtained in the first part. Okay, so this remainder will be equal to the digital sum that is obtained, and that is equal to 5. All right. So when this big number is divided by 9, then the remainder will be equal to 5. All right. So this digital sum rule is used to check the number's divisibility by 9. Also, it is used to calculate the remainder when the number is divided by 9. All right. I'll take one more example to clarify this thing. So let's say your number is 3279875633142. This is a big number. I quickly want all the students who are present in this session, I quickly want all of you to calculate the digital sum and tell me if this number is divisible by 9 or not. If it is not divisible, then what will be the remainder? I'll do it with you. So I can remove a 9. 2 plus 7 is also 9. I can remove that. 8 and 1 is 9. You can remove. 6 and 3 is 9. You can remove that. 5 plus 4 is 9. You can remove that. 7 and 2 will become a 9. You can remove that. All right. So the digits which are left will be only 3. So 3 is the only digit that is left. Okay. So the digital sum of this number is equal to 3. Okay. Now, since it is not equal to 0 or 9, so I can say that this number is not divisible by 9. All right. And when this number is divided by 9, the remainder obtained will be equal to this digital sum, and that is equal to 3. All right. So for the divisibility rule of 9, yes, you can use this digital sum. Now let's move forward and look at the last thing. The digital sum's usage to calculate or to check the divisibility of any number by 3. Now, once again, you can use exactly the same method. Okay, so calculate the digital sum. Okay, if the digital sum is completely divisible by 3, as in if the digital sum is 0, 3, 6 or 9, 0, 3, 6 or 9, then the complete number will be divisible by 3. All right. If the digital sum is not divisible by 3, then divide that digital sum by 3 and obtain the remainder. And the remainder hence obtained will also be the remainder when the number is divided by 3. I'll quickly give you an example for this. Okay. So let's say the number is 4739628. This is the number, and I am checking the divisibility of this number by 3. Okay, so first of all, I'll obtain the digital sum for this number. So digital sum के लिए 9 ignore कर सकते हैं. 3 and 6 can be ignored. 3 plus 6 will become a 9. 7 and 2, 7 plus 2 will become a 9. So I'm left with 4 and 8. So the digital sum for this number is 12. Now add these two digits and the digital sum finally will become 3. Now since this digital sum obtained is completely divisible by 3. Yes, it is. 3 is completely divisible by 3. So I can say that our number n will also be completely divisible by 3, and it will leave a remainder of 0 when divided by 3. All right. So this is an example using example to depict the divisibility rule of 3 using digital sum. All right. So friends, That is all about this session. The usage of divisibility, the usage of digital sum in calculations, as well as determining the divisibility rule of 9 and 3. So that's all from my side for this session. Now, some very useful piece of information for all of you. Any student who wants to join any of the programs, any of the batches to prepare for CAT 2023 or any other entrance examinations for management colleges, then we have a lot of batches which we have already started for the preparation of CAT 2023. The complete details of the comprehensive program that we offer in these batches are given on your screen. Also, you can enroll in any of these batches using the link that is given in the description of this session. So please have a look at that and be a part of BYJU'S Exam Prep. Also, whenever you want to join this program, do not forget to get the scholarship of up to 90% by taking this scholarship test, which is being conducted on 21st of January at 7 p.m. So please do avail the scholarships by taking the scholarship test, and you can register for the scholarship test using the link which is also given in the description. So do register now and avail the scholarship of up to 90%. Also, the students who are basically preparing for entrance examinations in this session, in the ongoing session, all India Open Mock for CMAT 2023 will be live starting from 21st of January up till 29th of January. So register for this examination once again using the link that is given in the description. Thank you very much, all of you, for being a part of this session. You can follow us on these social media networks, platforms, and to follow us, all the links are also given in the description. So thank you very much. Have a wonderful day. We'll see you once again with yet another session on calculation techniques. Have a nice day. Bye bye. All the best.